In this problem, we're given this circuit diagram and we are asked to find the current flowing through the 2000 ohm resistor. We're going to use the mesh current method, and to do this we are going to have to define the direction of our current. I'm going to have them going this way, so it's going to look like this for each part of our diagram. Remember, for mesh current method we're breaking this up into individual parts, so we're going to have this part, and then this part over here. All different parts because we are looking at the closed area for the voltage to flow through. It's part of Kirchhoff's voltage law. Now that we have all these in place, we can start defining our parts. I'm going to look at this first I1 right here, and then I'm going to look at I2, and then I'm going to look at I3. Once we have all of these formulas, we can plug them into a matrix and solve for our I1, I2, and I3, and then we would have our answer. So our first voltage is 40 volts. It's going this way, in opposition of our current, remember, because voltage goes into the positive and out of the negative. So we're going to have a negative 40 volts, and then we have a plus, because we're going to add all of the resistors, since in this specific part it's all in series. 300 and 125 is 425. This is in ohms, and this is for I1. Our 300 ohm resistor is next to our I2, and our I2 is going in the opposite way of our I1. So we're going to have to do a minus 300 ohms, and this is for I2, set equal to 0. So this is the first part. Next, we have I2 that we're going to look at. We're going to add all of our resistors, so 375 and 25. These are all together. That's going to give us a 400 ohm resistor, and this is for I2. Our 300 ohm, just like last time, is up against our I1, going in opposite direction. So we're going to have a minus 300 ohms for I1, then we'll have a plus here, and that is it for that one. That's the only thing that's touching it, so we can just set this equal to 0 and move on to the next one. We're going to look at I3 now. So we have a voltage right here going this way. It's 500 I delta, so we're going to have 500 I delta here. Since it's going in the opposite way, it's going to be a negative 500 I delta. We're going to add all of our all of our resistors together. So we're going to get 250 ohms of resistance, and this is for our I3. It's not up against our I2 or our I1, so we don't really need to put anything there. And this is set equal to 0. Now we need to find our I delta because this is an unknown, and then we can combine all of these together. If we look at our diagram, our I delta is here. It's going in the same direction as our I2. You know, our I2 is going this way, and our I delta is also going this way. Since they're going in the same way, they're going to be the same current for this closed system. So this is basically going to be I2. Our I delta is I2. Now I'm going to rewrite these, simplify a little bit, and write them in kind of a matrix form. Once we plug everything in, we are going to get this. This is our red row. The second row is our blue row, and the third row is our green row. For our matrix calculator, I'm going to represent our I1 as an X, our I2 as a Y, and our I3 as a Z. So these are all of the different substitutes that we're going to make. So looking at this, all we want to find is our Z. The reason all we need to look at is our Z is because we are looking for our I 200 ohm resistor. Well, our 200 ohm resistor is in here, and we know the current flowing through our 200 ohm resistor is going this way. It's the direction of voltage as well, because voltage goes into the positive right here and out of the negative. So it's flowing this way in the same direction as our I3. Since it's in the same direction as our I3, it's going to just be a positive, and we can use this I3 because it's a closed part of our circuit to be the I through the 200 ohm resistor. Basically, I3 is equivalent to I 200 ohms. Plugging this into a matrix calculator, we get 1 over 5 for X, 3 over 10 for Z, 3 over 20 for Y. So we want this 3 over 10 part. Now we know that our I3 is equal to 3 over 10, or 0.3. And this is the answer to this problem, as well as how to do it. If you want more problems like this, there will be a playlist linked below with a bunch of intro to circuit analysis problems, as well as notes that I use to study for this class and do these homework problems.